All right. Okay. So what I'm going to do is go to STAT, put in the explanatory variable in L1 and response variable in L2, and do a scatter plot. So the first explanatory variable is 5, enter, 15, enter, 30, enter, 35, enter, 50, enter, 72, enter, 105, enter. Okay, so I have eyeballed my list. Seems to be right. Don't forget to eyeball whatever you type in because people make mistakes. Okay, now the response variable is 69.1. The first candidate there is 69.1. Second one is 67.9. The third one is 66.4. The fourth one is 66.1. The other one is 64.9. 64.9. The other one is 64 even. The other one is 60.9. Again, you eyeball your data. They should be on the same horizontal level, and there should not be a large one. Suppose I see a 4-digit data here, then I know that I made a mistake. People make mistakes. So check your, eyeball your data and see that they're right. So after this, I'll go to do scatter plot. So I will do scatter plot in my plot 1. Make sure you turn it on. And I'm doing a scatter plot, so I choose the scatter plot. And then when I go down, L1 is my explanatory variable. My response variable is L2. So I think I got the settings right. So I'm going to zoom 9. So zoom, whenever you try to zoom 9 and your calculator has this squiggle wriggle here, second quit, then zoom 9 on zoom start. Okay. Okay, you eyeball your, what is it? You eyeball your data and you see that the scatter plot shows you it's going to be has negative slope. Excuse me, let me forgot to turn this on, but it's not too late to turn it on. Okay. So then I know I'm going to have a negative slope and a negative coefficient of correlation. So, and then I'll put a line here. But before I put a line, I'll go and turn diagnostic on. Does anyone remember where I get diagnostic? Anybody who remembers? I need to ask you this because this is one of the problems in exam. Somebody has forgotten unit 2 and they forgot to turn diagnostic on. Remember, you have to calculate coefficient of correlation, R, and sometimes R squared if needed. So turn diagnostic on, second catalog. And because I'm turning diagnostic on, I can quickly go to D, see where D is. Okay, there's my D right here. Okay, and I'll arrow down to diagnostic on and select that. Then I'll select again, so it's turned on. The essence of doing this is so that I will have my R and R squared. Also, I don't like long decimal points, so I can go to mode and turn my float to maybe 3 or 4 decimal points. That way I don't have a long 9-digit decimal point. So second quit. Now that I have done all these initials, I'll go to start, arrow to calc, and I'm going to do linear regression. That's what our class is doing. I'm going to select number 4, linear regression. And my L1 is explanatory, L2 is response. I don't have frequencies, so I don't need any, there's no frequency right there. And do you want to store your equation? I like to store my equation in Y1. Remember the argument, vars, Y vars, function, Y1. Remember that final exam is cumulative. That's why things in unit 2 are there. So when I hit calculate, now I can get my equation. So I have my equation, and also, so I can have my equation, and I can also graph. So I see that the line of best fit has a negative slope. In fact, if I push trace an arrow down, I will see that equation there. So let me write the equation. And by the way, you just write the equation as you are told to, and you should be able to answer all that questions. And then you can be told to estimate. You have to estimate within the given range, within the given explanatory variable. In other words, the smallest x is 5. You cannot be told, or even if you're told, you cannot extrapolate. In other words, if you're told to find the well-being of someone who is 60 or actually 50, you are not allowed to do that. Okay, or so you are, it's unstable. My internet connection is so stable. Why? Oh, please stop that. Okay, all right. So you can you have everything. You have R, you have R squared, and you have a high negative linear relationship between commute time and well-being. In other words, the commute time actually affects your health. If you drive 2 hours to work every day, or say 1 hour to work, especially if you're in the big cities, and your 1 hour may be actually 3 hours. Some people are sweating in the car. They're trying to say, because they have negative relationship. In other words, the longer you commute, the more it affects your health, whatever it affects, because there's a negative relationship between your commute time and your well-being index. I hope you know what we're talking about. The well-being index could be, you come back from work, you're fagged out, and so on. Anyway, you can answer all these questions. You have time to. Binomial distribution. Do we have time? Binomial distribution, number 9. Let's quickly do number 9. This is very important. All right. Number 9 is binomial distribution. Don't forget the formula, even though they're not asking you about the formula. Remember that the binomial formula is n combination r, success to power r, failure to power n minus r. Okay, well, this question is a cumulation. The sample space is 11, and they want you to find the accumulate from 4, because 4 is included, to 11, or to 0. So you're going to be finding P0 plus P1 plus P2 plus P3 plus P4. And I hope you know you can plug this in the formula, and then but you don't need to do the long method. So do the short method, cumulate. So I'm going to do binomial, because I'm cumulating, it is cumulative density function. Binomial cumulative density function, don't forget, because I am cumulating 1, 2, 3, 4, 5 points. So the argument is n, p, r, n, p, and then random variable. Okay, and remember that this random variable 4 is included because inequality says less than or equal to. Okay, and n is 11. So binomial CDF. The number is 11. The success is 0.35. It's given to us. The random variable is 4. Okay, and then I'll get my calculator and fit it in quickly. Don't waste your time because it's a timed exam. You have 90 minutes, so don't waste your time. We don't necessarily, because you're allowed to use your calculator, make use of your calculator as much as you can. You are being tested about being able to use your calculator also, speed and accuracy with your calculator. Anyway, this time I'm looking for binomial, not normal, and binomial cumulative density function. So this is binomial cumulative density function. The number of trials is 11. Success is 0.35. The random variable is 4, which means I'm accumulating to the left. And then I'm going to paste. All right, so I will paste, and it's asking me, is that the argument you want? Sure, that's the argument I want. So I hit enter, and the probability that of accumulating from 4 down for P4 plus P3 plus P2 plus P1 plus P0 is 66.83. I check the instruction and see if you're asked to put your answer in decimal or percent. Alternatively, you put your answer in decimal if you're not asked to. Okay, now let's do one, at least make sure we get to hypothesis testing. We did one confidence interval already. All right. I am going to number 10, hypothesis testing. That means we have touched almost every unit. We cannot do all of them from the beginning, but I know when I touched every unit. And I selected the most important things, especially the things that can show up in a test. If you do very well in Unit 4 test, you will do very well in final exam too. Okay, so let's go to number 10 and answer some important questions there. It says, test the hypothesis using the p-value approach. Be sure to verify the requirement of the test. By the way, what is p-value again? Let's make sure. P-value is the probability of accepting the null hypothesis, p-value. Important. If p-value is greater than alpha, if p-value is greater than alpha, you accept the null hypothesis, accept HO, which is the null hypothesis or the status quo. Otherwise, reject the null. Okay. Let's say again, if p-value is less than alpha, let me write it so that if p-value is less than alpha, you reject the null. Reject the null. All right. Okay. So that is the condition for using p-value. And this is another proportion question. So you must answer the question about conditions. Is the variance of this data greater than 10? If the variance is not greater than 10, you are not allowed to do inference. If the variance is less, you stop there. Okay. So I want to check the variance. Are the conditions satisfied? I already know that condition number 1 is satisfied because 200 is less than the population of America, less than 5%. N is less than 5% of population, of the population. So, okay, now condition number 2, is the variance greater than 10? Well, let's find out. the sample size is 200. The success is 185 divided by 200. And the failure is 1 minus 185 over 200. Because I'm using my calculator, I don't really have to simplify all this. I'm using my calculator. So I will quickly go to my calculator and put it in. But what kind of test am I doing, by the way? Look, we already told that it's a right tail test. So this is a right tail test, and I can draw a normal curve and show the rejection region. If I can be told to find the, and then, so what is the, by the way, I'm not even given, yeah, okay, see alpha. So this is a one tail test, so I do not divide alpha by 2, okay? And I will find the critical value for z 0.05. So I find that critical value and know when the boundary line for rejection region, okay, the boundary line for rejection region will be, I'm finding it because you might be told to find it. So inverse norm 0.05. And then the mean is the mean of a standard normal and the standard deviation. Okay, so we are not, and then we will calculate. Okay, so the normal curve is symmetrical, therefore the critical value for the right tail is 1.64. The critical value for the right tail is 1.64. Okay, so now we want to do the hypothesis test with our calculator. Trust me, you don't really have time to do them by hand, but unless you're told to do it by hand. So I go to start, go to test, and I am doing hypothesis testing for P, the critical value. I mean, the conditions are satisfied. Or what, did we check the conditions? I think it's satisfied, but let's check it though, even because we are actually told to check it. Before I continue, let's check it. Okay, so 185 divided by 200. We are told to check it, that's why I'm trying to go back and check it. Okay, and I have 0.925. Then I can multiply that quickly by the complement, which is 1 minus 0.925. 0.925. And then because that is the Q, and I get an answer, and I multiply by N, multiply by 200. I'm checking the conditions. All right, so 13 or 14 right there. Actually, it is 13,000. So it is greater than 10, so the inference can continue. So I'll continue the inference. The conditions are satisfied. So go to stats, row to test, and I'm doing one prop z test. Why one prop z test? Because the conditions are satisfied. Conditions for converting from binomial to normal. So one prop z test is number 5. And P is given to me as, of course, it wasn't given to me, but I can find it. P is not given, so let's find P quickly. Let's see. Okay, I see. I have 0.9. Sorry, 0.9 is here. Is the P value, the status quo, and X is that, N is that, and I'm doing a right tail test. And I'm going to, I like to draw, you don't have to draw. I like to draw in hypothesis testing, okay? Wow, that's beautiful. Okay, I want you to know that whenever the hypothesis testing, the normal curve has a lot of shading, then it means that there's a high probability of accepting the null. In fact, in this test, that's a high probability of accepting the null hypothesis. That's a very high. Is that what you have? Go back and do it. See if my own is too good. So let me go back and do the test because this is too good though. Number 5. Okay. The P, the status quo is 0.9. Okay. You know what? I have to put in because the one I put in now is the one I did before. Okay, no wonder it was too beautiful. Let's put in the actual data. Okay, and I'm doing a right tail. I'm doing it again because the data I use here are the old data. I'm using the new data right now. So sorry about that. Okay. Okay, now I want to draw again. Okay, the shading is not, it didn't cover all of them. Still, the p-value is 11.93%. The p-value is greater than alpha. Therefore, and actually, the z-value falls into the acceptance region. The z-value falls into the acceptance region 1.78. 1.78 is somewhere here. Oh, no, 1.17. 1.178 is inside the acceptance region, that is the z-value. But they didn't ask me to use the test statistics anyway. They asked me to use the p-value, and the p-value is 11 point something percent. 11% is greater than alpha of 5%. Therefore, accept the null hypothesis. And now that I have accepted the null hypothesis, I do not have enough evidence to reject the null. The status quo is still true, it's still working. I do not have enough evidence to reject the null because I accepted the null. Therefore, I don't have enough evidence to reject the null. I want you to know that you don't have any business rejecting the alternative. You do not have any business. So you are either doing with the null or accepting or rejecting the null. So then you go to whoever employed you as a statistician and tell them, oh, look, the null still works. The status quo is still working. There is no need to reject it. Status quo is still working. All right, this is number 11. It says find the sample variance. I believe that everybody can do that. Sample variance and sample standard deviation. I know you should be able to do that. All right. Data the right. What is this talking about? Find the number of classes. Oh, this is histogram. You should be able to do this one. I don't know. I think I have touched every unit, every section. Okay. Okay, this is question time. Question time. What other number do you think is we must do in review? We have less than 10 minutes remaining. This is question time. Both those of you online and those in class, I hope this helps. But I'm also recording it, so I can post the recordings in your. But do you have any question? I wish you luck in your final exam because that's the most important thing. If you're too busy, I don't know, some of you always have excuse, but if you're too busy to take Unit 4 test, because I already see some people did not take Unit 4 test, please go and take final exam. There will be no excuse not to take final exam. If you email me and tell me you forgot, that will not be accepted. Okay, somebody has a question. What is the password for the final exam practice? Wow, okay, I need to go get it. Okay, I'm going to go get it as soon as we finish. I'm posting this. Well, thank you, Zelki. Megan, I'll go get it. I didn't even know that I put password there. All right, I'll go get it. Good question. Good question from Zelki. I'll go get that. Any other question? Both those online and those in class can ask questions. When is the exam due? On the 30th of this month? In 2 days. I just want to make sure you know it's in 2 days. Today is 28th, right? It's due on the 30th. That is why I want to make sure that I review some of them. Does it help? Did the review help? Okay. Especially central limit theory. Especially central limit theory, people tend to forget that. All right. Sonja, did the review help?
Yes.
Okay, good. Let me see. Any other question from online? Any other question from online? Okay, that was a good question. I'm going to check and I will go to your announcement. If you forget anything about the exam, go to your class announcement and find it. If you forget anything about your class exam, go to your class announcement and find it. Is there any other question? Any other question? Okay, that is exam review on Zoom. You must be asking why I'm not using Blackboard Collaborate, because this is exam review for 2 classes. If I log in one class Collaborate, the other class will not be able to see. That's why I'm using Zoom. I just want to say this ahead of time, because some of you will be asking, why is she using Zoom? Because I combined the review for 2 classes, one online and one in class, okay? All right, I wish you luck. I know you're going to do well in final exam. Make sure you study. Give it your best shots, all right? Okay, if I don't see you again, you have a great Christmas. I may not see most of you again. You have a great Christmas, everybody. Do your best in that final. Some of you already, okay. You have a great day. I'm going to stop recording. All right. Thank you for coming for the review.